Assalamu alaikum viewers. Today I will discuss about turbine. In the industries, different types of turbine are available. So on the basis of steam condition, four types of turbine are available. One is called back pressure type turbine, second is called condensing turbine, and third is called extraction turbine, and fourth is mixed pressure type turbine. So on the basis of steam condition, these four types of turbines are available. Not only this, on the basis of extraction process, there are also three types of turbine available: impulse turbine, reaction type turbine, combined impulse and reaction type turbine. Viewers, today I will try to explain about function of the turbine, and not only this, I will explain how to start up turbine. So today I will discuss about back pressure type turbine. I will explain details in my videos. First time I will explain basic of back pressure type turbine. You think this is the boiler. Okay, you think this is the boiler. From this boiler, steam will go to the turbine. Before entry on the turbine, there are some equipment are provided. You think this is the control valve. Okay. From this control valve, this steam will go to the turbine. This is the control valve, and in this control valve are available one bypass valve. So why is provided bypass valve? Because for controlling steam pressure required bypass valve. This bypass valve is a 1 inch or 2 inch line. This bypass valve or 1 inch 2 inch line, and control valve is big line. If we open this control valve, how much flow is going, we cannot easily calculate. Before starting the turbine, we will warm up the turbine by this bypass valve. By this bypass valve, we will heating up the turbine. After we will open the control valve. After opening the control valve, we will close the bypass valve. So step by step I will show you. Today's topic is turbine. This control valve, there are one drain valve also available. So it will go to the, here is one ESB valve. First, you think this is the turbine. From the boiler, this steam will come to the turbine by this control valve. So first time it will come to the ESB valve. So it is called ESB, emergency stop valve. This valve used for emergency purposes, because if any problem coming, that time this lube oil will stop. Because if lube oil available, that time only this USB bulb open. If lube oil cut, that time this USB bulb will close. So if any problem, that time USB bulb will be closed. If USB bulb close, that time steam will not pass to the turbine. It will go to the governor valve. This is called governor. This steam will go to the governor valve. Main function of the governor valve controlling the speed by providing steam. This governor valve controlling the turbine speed by providing steam. If required to increase turbine speed, this governor valve more open and more steam flow will provide. This governor valve working by the actuator. Here is actuator. This actuator controlling the governor valve and governor valve controlling the turbine speed. If this turbine speed increase, actuator will give signal to governor valve for opening more, for giving more steam. So after it will pass to the turbine. This turbine are available rotor. This rotor side have rotating blade. These rotor side are available rotating blade. This is multi-stage turbine. In casing side available fixed blade. Like this. You can think this turbine design is like this. This is called shaft. This is shaft. This shaft attached with blade. It is called a rotating device. After entry on the turbine, this steam pressure will decrease by this stage. This steam pressure will decrease by this stage, and finally we will get this low pressure steam. In our plant, we are running back pressure turbine by 40 kg pressure, inlet steam pressure 40 kg, and our required low pressure steam 3.5 kg. For this 3.5 kg low pressure steam, so from this boiler we are providing 5 ton steam of 40 kg pressure in the turbine. After providing this 40 kg steam will entry on the turbine, and after passes this stage, steam pressure will reduce and turbine will produce electrical energy. By this electrical energy we can produce electricity. So by this way, this turbine rotor are moving. So from this electrical energy we can get electricity. But for getting this electricity, need to connect coupling. This is called coupling. Need to connect coupling with gearbox. You think it is gearbox? Need to connect coupling with generator, and after gearbox again need to provide coupling with this coupling attached generator. By this way, thermal energy converted to the mechanical energy, and finally mechanical energy converted to the electrical energy. Turbine from the boiler we are getting steam 380 degrees centigrade temperature. This steam will go to the ESB bulb. ESB, it is called emergency stop bulb. This ESB bulb using for emergency purposes. If any problem happen on this turbine, this ESB bulb immediately will close and this steam will not pass to the turbine. If lube oil system are normal, lube oil system are healthy, that time ESB bulb will open. If open ESB bulb, this steam will go to the governor valve. This governor valve are controlling turbine speed, but this governor valve getting signal from the actuator. It is called actuator. This governor valve getting signal from the actuator. From this actuator signal, this governor valve controlling the turbine speed. If turbine speed increase, the actuator will give command to governor for closing as per required below. If turbine speed decrease, that time actuator give command to governor valve for opening as per required below of turbine speed. Governor valve control the turbine speed. So if this steam will entry on the turbine, this turbine are multi-stage turbine, because turbine are available single stage and multi-stage. So in our plant, this turbine are multi-stage turbine. When this steam will enter on the turbine are available shaft. This shaft are available blade. So this blade with attached shaft, it is called rotating blade, and which blade is attached with casing, it is called casing. Which blade attached with casing, it is called non-moving blade, or you can tell this fixed blade. So when steam will pass by this way, this steam will hit on the rotating blade. So after hitting, this steam will pass here. This rotor will moving start, and the steam will passes by this way. So after passing, this thermal energy converted to the mechanical energy. So by these forces, this mechanical energy converted to the electrical energy. So by this way, we are getting electricity from the turbine. This is called gearbox, and this is coupling, and this is generator. With this shaft, any generator connected, that time possible to create electricity. But in our plant, we are using turbine for transferring the liquid from one place to another place. In this shaft, both side provided bearing. It is called bearing. Both side provided bearing. Why is provided bearing? What is the function of bearing? Normally two types of bearing are provided on the turbine. One is called thrust bearing, another is called journal bearing. So the main function of the bearing to hold the shaft, to reduce the friction, to help the shaft for easy movement. Fourth one is to carry the load of shaft. So this is the function of bearing. So in this turbine are also available MOP, mechanical oil pump, MOP. So when it will run, I will explain one by one. After passing steam from here to there, this steam pressure will reduce. After it will come out by this point. After coming out by this point, so here we will get 3.5 kg steam. 3.5 kg steam. In our plant, we are using this steam for the deaerator. You can use this steam in the deaerator, desalination unit, and this bulk urea storage area. As per design your plant, which point require this pressure steam, you can use this. After passes from this turbine, this steam pressure will come down 3.5 kg, and after it will go by this NRB bulb. This is called NRB. NRB means non-return bulb. This is non-return bulb. This main function of the non-return bulb only passes the flow, but it will not back. From this wave, flow can pass, but from there, flow cannot go to the turbine. This is the main function of the NRB. So after passes the NRB, this steam will go to the isolation valve. After it will go to the, this is safety valve. Why we are using this safety valve? We are using this safety valve if anyhow in this line steam pressure increase, required to reduce steam pressure. If here steam pressure increase, that time the safety valve will open and this line pressure will be controlled. So this safety valve, you can provide some set point for opening the safety valve. So in this line 3.5 kg, so safety valve set point makes a minimum 3.8 kg. If 3.8 kg pressure on this line, that time safety valve will open for controlling the pressure. After this, it will go to the where? It will go to the deaerator, desalination, which point required 3.5 kg steam. This point it will go. So here is one band valve. So we are using this band valve startup time. In the startup time, we are using this band valve for heating up the line. You can see here also available drain valve. This drain valve are using for removing the condensate. So we are using this drain valve for removing the condensate. High pressure steam line drain valve, and this is low pressure steam line drain valve, and this is some plant, this casing drain valve are also available. So this is the main equipment of the turbine. So in the turbine also required cooling water system and this oil system. Now remaining oil system and cooling water system. So now I will try to explain about oil system. So you can think this is the auxiliary oil pump. You can think this is the auxiliary, this is the oil tank or console tank. From this oil tank, oil will discharge by this pump and it will go to the bearing. It will go to the bearing, to the actuator. This oil will go to the actuator. You can see by this line. Go to the actuator point. Oil will go to the actuator point, bearing point, and this ESB valve. By this oil pump, this oil discharge to the bearing point, go to the actuator, and it will go to the ESB control valve. After it will discharge from the bearing. It will discharge from the bearing. It will discharge from the bearing, from the bearing point, and this point, and finally it will come out. Finally it will come out. This is the cooler. Finally it will come out by this cooler and it will again come to the oil tank. The oil tank oil will provided to the bearing point, actuator point, and this ESB valve area and this actuator point. So after this bearing, actuator, ESB and actuator, this oil will discharge by this line and it will come to the cooler. Why it will come to the cooler? Because after discharging from this point, this oil temperature will be increased. For controlling the oil temperature, for reducing the oil temperature, using oil cooler. From this oil cooler, from one side cooling water in, cooling water once from downside cooling water provided, from top side cooling water discharge. By this way, this oil temperature will reduce. Cooling water out. This oil again will go to the console tank. This is called console or oil tank. Console oil tank. It will go to the console oil tank. So viewers, this is the main accessories. This is the main accessories or main equipment of the back pressure turbine. So in my next videos, I will explain how to start this back pressure turbine. So I will give full explanation of back pressure turbine. After watching this video, if you like my video, if you comment on this video, next time I will explain extraction type turbine, condensing type turbine, and mixed pressure type turbine. One by one, I will explain startup. Before startup, what types of action are required, and which one will you start first, and which one will you start after. So I will try to give full explanation of SOP, standard operation procedure of back pressure type turbine.